I'm wearing a watch. And every single time I put on this watch, I notice that I'm wearing a watch, right? I'm walking around, I'm kind of like, I kind of got to get it settled. And perhaps I'm just not good at fitting the watch. That is definitely possible. But the thing is, no matter what, I always forget that I'm wearing a watch immediately after. Like right now, are you aware that you're wearing a shirt? Hopefully, you're wearing a shirt. Or socks or pants or anything like that. I mean, if you really pay attention, there's always going to be some superficial awareness, and we're going to be able to see exactly why that is to an extent too. But at the same time, you don't feel these things constantly. I mean, can you imagine a world where you always felt your shirt the same way as when you put it on? That's a crazy world that I just don't want to be a part of. Well, to answer this question of what's exactly going on here, we're going to be using one of Kenhub's brand new physiology study units. This is a premium feature so premium features mean they come with like videos, they come with quizzes. These are absolutely amazing value. It's like this really dense lesson that comes with everything you're going to need to know. This is all about the mechanoreceptive somatic senses. So these premium features are amazing, but at the same time, if you sign up for Kenhub, you're going to get access to all of our images. You're going to get access to all of our articles, which we have hundreds, if not thousands of articles for you to look at. But we're going to go ahead and leave a link to a separate but equally amazing study unit on the reflex arcs down in the description below. So go ahead and check that out and just sign up, and you can just see everything else you're going to get right away. It's going to be awesome. So to answer this question, we're going to be going ahead and looking at this image here. So I'm going to go ahead and click this so we can see exactly what is happening. And so the basic idea here is, well, there's a butterfly and it's going to land on the skin. So how do you know that a butterfly is landing on your skin? Well, this is before that all happened. So let's kind of explain everything we are seeing here. So you can see the hand, you can see the butterfly, then you can see the skin right here, and when we can see a sensory cell. So if we zoom in on this, what you're going to see is we're looking at the neuron itself. So this is one of those sensory neurons that's going to be detecting the butterfly. And outside of the neuron is the extracellular space. And there's going to be fluid inside of that space, to no surprise, called the extracellular fluid. Now, on the outside, you're going to have a lot of sodium. That's exactly what we see here. So the Na+, that's telling you these are sodium ions. Now, there's also going to be sodium on the inside. As you can see here, this is called the axoplasm. So we're looking at the inside of the neuron, but there's less of it here than there is here. And that's why you're also going to see these positive signs, and then you're going to see these negative signs. It's not that the axoplasm or inside of the neuron is negative. It's that it's less positive than the outside of the cell. So we have a literal difference in the charge between the outside and the inside of the cell. So we then have these mechanically gated ion channels, right? So that's going to be these yellow things. And so when I say mechanically gated, what that means is that they respond to pressure. So if we go down here, so we can see the butterfly is landing. This is a magical moment, by the way. The butterfly lands on your hand. You have good things happening in your life, right? So this is going to create a touch stimulus, and we can see that here. So we have this downward arrow, and then you can see these cute little legs of the butterfly pressing into the skin. And what's going to happen is they are going to mechanically deform the neuron. All right, so if we zoom in here, it's the touch stimulus. You can see all the phospholipids. That's basically the plasma membrane of this neuron. You can see that it's being deformed, and when that happens, what's going to also occur is these mechanically gated ion channels are going to open. And when that occurs, the sodium is like, yes, I am going in. And the reason being is because there is, again, more sodium on the outside of the cell than there is on the inside. And so the sodium ions are naturally going to go where there is less, right? This is all just basic physics here. And so as this occurs, what that is going to do is we can see that now it's more positive, right? So we still have negative over here, but now we have like this region of positivity on the inside. But then that also means it's negative or more negative on this region here. So what's happening is we've created a receptor potential. A receptor potential is not going to be an action potential. So we're going to get to that in a second. It's basically just saying, all right, something's happening, but is it enough to be aware of it? That's the question we want to ask. So let's say it is, all right? So what's going to happen is this receptor potential, if enough sodium ions are actually going to enter into here, because I want you to think about it. If we didn't have it this way and just the physical any kind of physical stimulus would allow sodium to go in, and that automatically causes an action potential, which means that that neuron is firing the signal, and you are going to experience that neuron's, whatever that neuron is responsible for, you would feel absolutely everything at all times, no matter what, right? That would be not good. So we have to have some kind of system of monitoring what, like you have to, it's like you got to cross this threshold. You got to get here. And once you get here, that's exactly what we see in this third image, right? The action potential is generated. So let's say that it does stimulate enough sodium ions go in. Well, what's going to happen is that receptor potential is going to lead to this voltage gated ion channel opening. Right, so as that voltage-gated ion channel opens, more sodium comes in. This is actually going to cause an action potential, right? The inside of that neuron is now positive enough. It has crossed enough thresholds where what's going to happen is an action potential is going to shoot through that neuron, which is obviously going to go to your spinal cord, go to your brain, and you are then going to be processed that you are in a magical moment with a butterfly. Right, so you have to get that voltage-gated ion channel to open, and you get that from enough sodium ions coming in here, right? So I think this is probably going to be making sense to you, but it doesn't quite answer what's going on with my watch or the shirt. So let's go ahead and look at this, and then we can see that not all sensory neurons are the same. All right, we can actually divide them into what are called rapidly adapting receptors and slowly adapting receptors. And this adapting is the key word here, because what we were just talking about here is transduction. All right, this is basically, we're just saying, we're causing an action potential, we're causing these things to occur. But again, nuance matters, right? Do you need to feel everything at all times? No, and that's where you're going to want adaptation to kick in. So we have these things called rapidly adapting receptors. You can basically think of these as adapting to change, right? They are there to sense change. So what we can see is the intensity of the stimulus here on the y-axis, and then time here on the x-axis. So we have nothing happening, and then boom, something is occurring. An intense, the stimulus is intense, right? And it gets up to this level, and then it just stays consistent. So butterfly lands, oh, I feel it. Butterfly stays there. Butterfly leaves, flies off, no more stimulus, and you go back to that neutral position. All right. So by the way, you look here, it's the exact same thing between the rapidly adapting and the slowly adapting, right? So again, butterfly lands, chills, leaves is exactly what we're seeing here. Well, in these two types of sensory neurons, these are called mechanoreceptors. Mechanoreceptors are there to just sense mechanical pressure. So we have a Pacinian corpuscle or a lamellar corpuscle, and then a Meissner corpuscle or a tactile corpuscle. And what we can see here is what's happening. So butterfly lands, right? What's going to happen is you can see like between these, they're sending their action potentials. So it's like little pitter patter of the feet, the butterfly's landing. It's like, oh, something changed. Boom, boom, boom. 3 action potentials. Boom, 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 boom. Is that 5? 5 action potentials. So the Meissner corpuscle is actually more superficial. And then the Pacinian corpuscle is actually going to be a little bit deeper. But then it's like the butterfly is relaxing or just resting. It's just hanging out, just enjoying being a butterfly. You'll notice then that what happens is we don't have any more action potentials, right? What's going to happen, and this is what's occurring with my watch, with the shirt, right? When you put on your shirt in the morning, you are feeling that because there is change occurring on your skin. And if you really pay attention as you're moving, I can now feel my shirt kind of sliding around. So I can sense that change. And so that is going to cause these rapidly adapting receptors to send an action potential. And then I'm going to be aware of what's going on. But then it's like, it's nothing, right? Because it just sits there. You don't need to, because again, that's just overwhelming for the nervous system. But as soon as the butterfly leaves, or you take off your shirt, or you take off your watch, you've changed again, and boom, that's exactly what's going to happen. You feel it, an action potential shoots, and then you're back to that normal position. That makes sense. Now, the slowly adapting receptors, though, because you also want to be aware that something's going on, right? It's not like you don't want to feel anything at all. So with the slowly adapting receptors, this is where we see the epithelial tactile complex and then the bulbous Ruffini corpuscle, right? Both of these are going to be also responding during that initial change, but they are then going to be sending continuous action potentials. Now, as you can see though, it's like, look at this. This is actually kind of important. You can see that it's like these action potentials are really close together. You can see it the same here with the tactile corpuscle. And then it starts to get a little more distance and a little more distance, a little more spread out over time. And that's because it's like, okay, everything's okay. We're not changing, but it's still there. Still there. Right? And that's exactly what's happening between both of these. And that is, again, these are going to be at different depths inside of your integumentary system or inside of your skin. And it's there to just let you know that it's still there. But this is not enough to just dominate your awareness because, again, that would be absolutely ridiculous. So you have these rapidly adapting receptors turning off, but you have the slowly adapting receptors just kind of like slowly figuring it out. I mean, like, okay, we're definitely doing all right. I think this is so cool. I love talking about this in the classroom with students. I'll just like look at them like, why can't you feel your shirt? But as soon as I say that, they're all like, oh my God, I have a shirt. I can feel my shirt. It's kind of like if you say like, don't focus on the elephant or, don't focus on the fact that you're not controlling your breathing. You're immediately controlling your breathing. But it's still really fascinating to see how all of this works. But yeah, this is just one image. There is so much more inside of this study unit, all around mechanoreceptors and the mechanoreceptive somatic receptors. So this is just really, really cool. Again, the quizzes, the videos, those are premium features. But if you sign up for Kenhub, you're going to get a whole lot for free, including all of our Atlas images and our 1,000+ articles. Like, look at this one. It's all on sensory receptors. I mean, this is basically a medical encyclopedia. Yeah, basically, it is a medical encyclopedia breaking down everything for you. So we're going to go ahead and leave a link down to this one down in the description below, as well as that free study unit on reflex arc. So be sure to check that out. But thanks for hanging out with me. I really appreciate it. While you're down there, by the way, go ahead, hit that like button, subscribe, all that normal YouTube stuff. But I will see you in the next video.